Hello everyone, welcome to a new video of Maths Senior Secondary Course NIOS. In this one, we are going to cover the chapter Relations and Functions 1, Relations topic, Type of Relations, and Domain and Range. So these are the topics that we are going to see in this video. Before starting the video, I would like you to subscribe to the channel, give it a thumbs up if you like the content, and share it with your friends. So let's begin. So the first topic is relations. What is a relation? So in maths you have relation, which is a relationship between two sets. So the word meaning of relation is having connection with someone in some form. So the same way when it comes to mathematics, you have got sets. Let's consider A and B are two sets, and the relation that they share between both of them, that is known as relation. And if we're given with two sets, that is A and B, then A is related to B through some unique relation. That is known as relation in maths. So here A is called the domain and B is called the range of the relation. Okay, so this is done, right? We have got different types of relations. First one is empty relation. We are discussing some relations which are required for your chapter. So empty relation, then comes reflexive relation, then comes symmetric, reflexive, symmetric, transitive, then comes equivalence, then universal, inverse, identity relations. Okay, these are the basic relations that are there. We have to focus on empty relation, we have to focus on universal relation, then identity relation. These are mentioned in your lesson. So let's see what are they. Let's go to the chapter. So we are here, relation topic. Now first kind of relation is void relation or empty relation. What does it mean is, if the relation is 5, that means no relation exists between set A and B. Okay, for example, set A having element 1, 2 and 3, set B having element 5, 6 and 7, and a relation is there between x and y where x plus y is equal to 22. So at any point of time you will not get any elements from A to B which gives the sum as 22. So this type of relation we call it as empty relation or void relation. That means it doesn't exist at all. So that is one kind of relation. Next one is universal relation. So the relation is from A to B, that is from set A to set B, and that kind of relation is known as universal relation, in which all the elements of the set are mapped to another element of the another set. Okay, that kind of relation is known as universal relation. Example would be, if A has the elements 4, 8 and 12, B set has the element 1, 2 and 3, and consider the relation from A to B is x greater than y, where x and y belongs to this relation. Okay, x and y are the elements from A and B respectively. Now if you see, elements from B are always smaller than A. That means the A elements, that is 4 is always greater than 1, 8 is always greater than 2, then 12 is always greater than 3. So this relation is applicable for all the elements. So such relation is known as universal relation. Okay, this is another kind of relation. Next one is R is a relation which is defined from A to A, that is from the set to the same set. Okay, and such type of relation is known as identity relation. So example would be, if you have got elements 1, 2, 3 in a set, so the identity relation can give you the result as ordered pair would be 1, 1, 2, 2, 3, 3. Okay, these are the resulting set if you apply the identity relation. So these are the types of relations that are mentioned here. Now let's see the next topic, that is domain and range. So what is a domain? Already we have discussed that if R is a relation between two sets, then the first elements of the ordered pair is known as domain, and the second elements of the ordered pair is known as range. Okay, domain, range. Let's see an example here. Set A has 4 elements: Mohan, Sohan, David, Karim. Set B has Rita, Mary and Fatima. So if you talk about the ordered pairs, the relations, here you can see these are the ordered pairs that are in the relation. These are the ordered pairs. Okay, so this way, this Mohan, Sohan, David, Karim would be defined as the domain, and range will be the second element, that is Rita, Mary and Fatima. That is what discussed here. Okay, let's see some examples. Example is given as element in A sets are 2, 4, 5, 6, 7. In B set it is 2 and 3. So R is a relation from A to B defined by this. Okay, A is divisible by B, where A belongs to A and this B belongs to your B set. So A should be divisible by B. In that case, you have to take out only those order pairs. So if you see 2, 2, that's possible. That is one set. Next one is 2, 3, not possible because this is not divisible. Next one is 4, 2 is another pair which is divisible. 4, 3, not possible. Then comes 5, 2, not possible. 5, 3, not possible. 6, 2 is possible. And next one is 6, 3, that is also possible. 7, 2, not possible. 7, 3, not possible. So these are the resulting ordered pair because of this kind of relation. Okay, so R in the roster form will be this result. Then comes domain of R. So domain of R would be 2, 4 and 6, the first part of the ordered pair. 2, 4 and 6. Okay, 6 is repeated here, so you can say 4, 2, 4, 6 are the domain. Next one is range of R. Range is the right side or the second element of the ordered pair. Answer would be 2 and 3. This 2 is repeated here and comes 3. So 2 and 3. This is the resulting range. Then represent R diagrammatically. That is, here you can see in the diagram, A set has the elements 2, 4, 5, 6 and 7. B has 2 and 3. So define those relations which are existing here. So 2, 2 is existing, 4, 2, then 6, 2 is also existing. Okay, the 3 are done. Then comes 6, 3, that is also available, and this shows that this set has a relation with B. Okay, so this is diagram for your this relation. Okay, hope you understood how to do this kind of question. This looks complicated, but it's very simple to do. Understand the question properly. One more question. Here R is a relation is greater than from A to B. That means elements of A greater than elements of B. So these are the given elements of A and given elements of B. You can check here. Solution would be 1 1 is not existing, 1 2 not existing, 1 6 not existing. Okay, because A element should be greater. 2 1 possible, so that is written here. Then comes 2 2, which is not possible. 3 1 possible, 4 1 possible, 5 1 possible. So 3 1 4 1 5 1. So all these elements are taken out. Then comes 2 2, no, not available. 3 2, because 3 is greater than 2. Then comes 4 2, that is also available. Then comes 5 2, which is also available. Now check 4 1. Okay, that's already mentioned here. 4 2 mentioned, and 6 is greater than all of them, so that relation won't exist. So these are the resulting relation or the ordered pair. So here next question is domain of R. Domain is the first part, that is 2 3 4 5. 2 3 4 and 5. This comes under domain, and range is 1 1 2 1 and 2. So these are the elements in the range. Hope you understood how to do this question. Practice more questions so that this becomes much more clear for you. Next topic is codomain of a relation. So codomain of a relation can be explained as all the output that can come as a result of the relation, that we call it as codomain. Okay, for example, if a relation is from A to B set, and B is known as codomain with all the possible values. Okay, so already we know what is a domain, comes from the first part of the set in the ordered pair, and range is the second part of your ordered pair. Okay, so this exists, whereas codomain is the possible outputs that can come out. Okay, that's a possibility. All the possible outcomes that can come out is A set has elements 1 2 3 4 5 6. Define a relation from A to A by this, where B elements are, or the ordered pair second elements are elements of A plus 1. Okay, write down the domain, range and codomain. So the ordered pair or the resulting pair will be like whatever you have in the first set, the next element pair will have, the first pair will have element, and the second element, second ordered pairs element will be one more than that the first element. So element is 1, next element will be 1 plus 1, that is 2. 2, then for this 2 plus 1 3, 3 3 4 4 4 5 and 5 5 6. Okay, since 6 7 is not possible because 7 is not here in this given domain or given elements. These are the relation that is defined. So domain of A will be 1 2 3 4 and 5. Okay, taken from this ordered pair. Range will be 2 3 4 5 and 6. So this is domain and range that we have already learned. Now codomain is all the possible values which are there. So the possible values, what all are available, you have to write it. So that is 1 2 3 4 5 and 6. So this is what codomain. is it is all the possibilities. These are the exact values that you get from the relation. Okay, this is what codomain of a relation. Hope you understood. If you have got doubts, please do comment in the comment section, and thank you for watching. See you in the next video.